The Hangar 9 P-47 comes in a rather smaller size box than one would think, though it's not that small. So let's look inside, shall we? Not surprisingly, a good chunk of the box volume is taken up by the chubby fuselage. The fiberglass cowl is sturdy and well painted with a nice matte finish. Dummy engine cylinders are done in vacuum-formed plastic, but they're also quite sturdy, with about as good a detail you can get with this technique. On to the wings. Lots of printed on panel lines and quite obvious cutout for the wheels. Small bits of tape hold on the servo hatch covers. Ailerons are pre-hinged but not glued. I was quite impressed with the flap construction and matching wing cutout. This is very close in design to the real one. Of course, there are pull strings for the servos. Not surprisingly, there are several large bags of hardware. I actually think there's a kitchen sink in there somewhere. The tubby fuselage sports more panel line details and a factory fuel-proof firewall. I don't recall seeing any wrinkling in the covering. Easy-to-operate latch opens up a cavernous fuselage which has some nice engineering and construction. Lots of room for servos and associated electronics. The top hatch appeared to be both light and sturdy with vacuum-formed canopy. Bottom rear removable hatch gives access to the tail wheel mount. Have I mentioned this was a pretty big model? I can see why it's called the Jug. The manual has detailed parts list and each step has an accompanying black and white photo. Of course, can't forget the decal sheets. On the wing and the prayer. Yes, we start with the wings, more specifically, the flaps. Find a slot for the control arm and remove the covering. Now do the same for the offset hinges. Test fit the hinges before gluing to make sure that everything moves smoothly. At this point, epoxy in the control arm. Then epoxy in the flaps. Be sure to carefully align the hinge points. Hinges are easy to insert and glue in with thin CA. And more trimming of the covering for the aileron servo linkage exit. This is where I noticed that the covering is some sort of self-adhesive type and not heat activated. Interesting. The standard size Futaba servos I use did not fit the cutouts in the mount, so I needed to open up the slot a bit with a file. Now that the servo fits, I can screw that baby in there. While I was at it, I used a pull string to feed the servo wires through the wing. And screw in the servo plate. The aileron control rods need to be cut to length, so I marked it with a Sharpie. Make an L bend, clip off the excess, and lock into place with a keeper. It's a similar technique for the flaps, but in this case, be sure the servo is not centered but at the full up position. A quick test shows a bind-free operation. Okay, so the P-47 as it comes from the factory does include a setup for fixed landing gear. And they do include a set of wheels, which are fairly nice and decent enough. And actually pretty interesting. They have a nice set of shock absorbing struts. and a mounting plate for the fixed gear. Looks like a welded plate with a receptacle with a set screw. Things fit in here like that. And so if you want to do a fixed gear, it comes from the factory like that. But of course, any good scale person is going to want retractable landing gear. So I got the aftermarket scissor struts from E-flite, which are really nice. Looks a lot more scale. And of course, the set of retracts. These are 85-degree retracts for the 60 to 120 size aircraft. And so these are beefed up retracts, which will attach to the scissor struts, and then I'll attach the wheels. I upgraded the landing gear with the spring-loaded oleo struts option. All metal 85-degree large-scale electric retracts from E-flite were used and are a drop-in replacement for the kit's fixed gear. To mount the oleo struts, I needed to remove the stock spring wire and adapter first. To help keep the wheel axle secure, I ground in a flat spot for the set screw. Be sure to use thread lock on all screws. Next was to remove the excess covering from the wheel wells with a sharp knife. The retracts fit perfectly and just needed to be screwed in. Gear drawers have pre-made pilot holes that needed to be drilled out for the strut mounts. A quick test showed a smooth operation of the retracts. Pre-painted wing tip navigation lights and their respective covers are vacuum formed as a pair and will need to be cut out and trimmed. Canopy glue is used to affix the pieces in place. Oh, and make sure the red light goes onto the left wing. Use tape to hold into place as the cover didn't quite match the curved wing. At this point, I slid in the wing tube so that I could temporarily mount the wings to the fuselage. This is done so that we can align the tail. Except I gotta remove the support stud first. So anyways, slide the tail in and make sure everything is symmetrical and straight before marking where to remove the covering. Just a light touch with a sharp razor will do it. I like to use 30-minute epoxy for jobs like this so as to get plenty of working time. It's a scale model, so better make it look nice and clean off the excess residue. Once cured, finish gluing in all the moving bits. And more control rods. You know how it goes. The tail wheel is kind of neat and already assembled. Just pop off the bottom hatch and screw in. Connecting the control rod was a little fiddly, but not that bad. In fact, it all worked out quite nicely. Okay, so I'm making pretty good progress on the P-47 so far. In fact, the wings, I think I can stick a fork in them. They're done, as I've got the servos installed, the retracts are installed. I've got the wing lights are glued in and in place, so there's really nothing else to do on the wings. As far as the fuselage, I've got the servos installed, and they're all connected to the tail surfaces, which are glued into place, and even got the tail wheel working, so I'm pretty happy with that. So far, everything's been pretty straightforward. So the next step is to install the engine, and this is something I've been a little bit apprehensive about, since the kit is designed for the Evolution 20cc engine, and the Evolution engines are pretty much kind of just like this glow engine. They have a carburetor in the front, they have rail mounts, very much like installing any type of glow engine. The interesting thing is, for this kit, I'm actually going to be using an RCGF 26cc engine. And Eagle Eyes knows the first thing is the carburetor is in the rear. And although this does use the same type of rail mount as a glow engine, having the cover in the rear offers some bit logistical differences and challenges as far as hooking up the throttle and now a choke. And I'll have to admit, I've never built an RC model with a rear engine carburetor. This would be my first time setting up something like this on a gas engine. So I'm facing a little bit of trepidation on this, and I'm just going to use my best engineering judgment and try my best and see how it goes. Included are several drill templates for the Evolution and Sato engines and Power 60 electric motor. Fortunately, in my case, the Evolution template also worked for the RCGF engine. Yes, that'll do just nicely. Plenty of space on the rails for the rear carb offset. So to use a template, place on the firewall label side up. Mark the holes with a fine tip Sharpie and drill holes large enough for the blind nuts. With the rails mounted, I measured the recommended shaft distance per the instructions and clamped the engine into place. Using a Dubro centering tool, pilot holes were marked for the screw holes. A test fit showed everything lined up perfectly. Now to tackle hooking up the rear throttle and choke controls. I needed something more flexible than the stiff rods in the kit, so a trip to the local hobby store netted some semi-flexible nylon push rods. Just what I was looking for. I needed something bendy, but not too bendy. You'll see why in a second. Next was to add a ball clevis to the throttle lever. I think I will use something different on the choke. First, I needed to make a makeshift template to mark the drill points. Using the mark I just made, drill for the throttle sleeve. Here's where I noticed the near center line of the cable will cause some issues with the fuel tank positioning. So I'll need to rotate the servos around to make an offset V groove in the rods to make space for the tank. After double checking the alignment, assemble the control rods. And test mount the engine again. It's no surprise I did a lot of test fitting. But in the end, no surprises. Everything worked smoothly. The choke used a simple Z-bend as it needed to be lower profile so as not to interfere with the throttle, and I didn't need to be as precise in control. Note that the tank fit nicely between the rods now. Servo test showed everything worked great. The servo control choke is gonna be awesome. Okay, so the part that I kind of dreaded the most has turned out to be actually really not that bad. I've really pretty much completed the throttle and choke setup. I decided to get really fancy and have two servos, of course. Well, one is for the throttle and one is for the choke. I figured, hey, let's have some fancy remote controlled choke action going on. And I like how everything's turned out. I think that the fuel tank will fit right nicely in between the two control rods right there without too much problem. I might have to trim the braces a little bit, but other than that, I think it'll work just fine. Actuation, seems to work pretty good. I think I need to brace the cables a little bit better, but that's a real simple thing. But I've got the cable set up so that the throttle doesn't interfere with the choke. The servos seem to have plenty of torque to operate the choke. It was a little bit kind of stiff, but it seems to be not a problem. Fortunately, they don't require a whole lot of servo throw, so not a whole lot of torque is necessary. And so I really think this nice smooth operation, the semi-flexible rods seem to do just a trick, and a little bit of epoxy to set everything in there. And I think we are pretty much good to go. Really, the only thing I need to do is set up the endpoints on the transmitter so I don't over control anything. But other than that, I think I'm really good to go to finish up the setup. I gotta put the muffler and cowl on and see what else instructions tell me to do. This should be interesting. It has a pit style muffler, so I hope it fits in there pretty snugly, I guess, or mostly. But other than that, I'm ready to proceed to the next step in construction. Dummy radio insert needed to have the center marked and drilled. First with a small bit, then a large stepped bit. The hole was enlarged further with a knife and then cleaned up with some light sanding. Air-cooled engines need air to cool, of course, so I needed to cut out some sections for airflow to pass through. It was easy to do with a few corner holes and a hobby knife. Be sure to sand off the paint before gluing the insert into the front of the cowl. The cowl uses these little brackets to screw onto the fuselage. I attached the brackets to the fuselage first, but the cowl wouldn't fit until I made a notch for the ignition sensor first. There we go, that's the ticket. Okay, so back to the cowl mounts. I needed to make sure the cowl was all the way on, and a good indicator was the fit of the lower section. It needed to overlap by a few millimeters, which looked good and allowed for adequate propeller clearance. Satisfied with the alignment, I placed a few drops of glue on the brackets, just enough to hold them in place. First thing I noticed was that the brackets didn't fit as well as I'd like. Notice the gaps. So I glued in extra scraps of plywood to fill the gaps and provide more surface area to glue to. While that all dries, I figured it was a good time to work on the cockpit, which I must say is quite nice with pretty good sidewall and dashboard details. Though I'm pretty sure whomever did the spelling wasn't American. Despite the anime eyes, the pilot figure is well detailed, though I'm not so sure about the colors, however. Foam tack type glue was used to mount the pilot due to the figure's use of a soft foam bottom. Let's hope it holds. Attaching the pit-style muffler immediately posed a problem. The exhaust pipes interfered with the fitting of the cowl and prevented it from sliding all the way on. So how do I fix this? Ah, I got it. If I rotate the muffler 180 degrees, the cowl will now fit. Now I can't fly it that way, of course. But what I can do is draw alignment lines to mark where I can now glue on some dummy pipes made of wood that are shorter. This lets me mark where the exhaust holes should be drilled into the cowl with, you guessed it, a Sharpie. Now drill a couple of small pilot holes. Then go big. And even bigger. Now connect the two holes by using a rotary cutter and some filing. Now the cowl fits on. Mostly. It wasn't perfect, but pretty close. Just some additional light grinding gets me to the fit I need. The results are quite satisfactory without being overly large. Okay, so back to the cockpit. With the pilot now glued in, I made some alignment marks with tape. Then glued into place with canopy glue. Okay, at this point the core construction is done, and we're left with parts that look to be vent details. Again, canopy glue to the rescue! Panel line details make these detail placement foolproof. Wing bomb mounts are screwed into the wing once you find and clear the screw receptacles. Last bit of details are the plastic machine guns, which I use a bit of medium CA to hold in place. A couple of pieces had a tight fit, which required an extra bit of convincing. With the end in sight, I moved back to the internal stuff by assembling the fuel tank. And test fitting the tank brackets. But before mounting the tank, I needed to find a place to mount the ignition module. While the flight battery fit just fine, the ignition module is too big to fit next to the tank. Fortunately, there's extra space under the tank mount. But first I spread some epoxy onto the surfaces for better adhesion of Velcro. There are knockout panels in the firewall for the ignition wire, which took a little convincing to remove. So laid on the Velcro and installed the ignition module on the floor plate. It's almost like it was intended to go there. Instead of the top wood bracket for the tank, I use a Velcro strap for easy removal. The rear bracket was glued in, however. And now to finish hooking up the plumbing. And then the control check. Wait, that's not right. One of the elevator servos was reversed and needed a reversing module. There, much better. Just a bit of tightening up the wiring and installing the switches. I use one for power and one for ignition. An engine won't run without a spark plug, so in it goes. The plug cap took a bit of force to snap on. No worries about it falling off. And lastly, the ceremonial installation of the propeller. Houston, we have a plane. And one final systems check before cranking her up. Join me for part 2 when we start her up and take this jug for a spin.